Hello, and welcome back to the Multimedia System and Design class. In our first lecture, which is Unit 1, we spoke about what multimedia is and talked about the components or elements that make up a multimedia, text, sound, images, videos, and the rest. In Unit 2, which was our second lecture, more or less, we also talked about text. We delve into the multimedia component text and spoke a little bit about what multimedia, this type of multimedia, what it really is. In today's lecture, we're going to talk about sound, which is also a component or um, an element of a multimedia system. Now, when we talk of sound, there are other things that goes into sound. So in Unit 3, this is going to be the objective for the unit. So at the end of this lecture, students will be able to have an idea, or students will be able to have an idea of what the multimedia system sound is. They should be able to describe the multimedia system sound. And again, they should be able to also understand the digital audio. And that is one of the good things that, students should have an idea of. Now, with that in mind, we will also move on to the state of a MIDI audio. A MIDI is an acronym which we're going to talk about and explain those into details. We will also talk about audio files and how we will be able to enumerate audio files formats, putting it in different file formats and the rest. We'll explain into details what MIDI is and how best it is compared to other digital audio. We will discuss audio CD playback. Students will also have an idea what the audio recording is and also explain voice recognition and response, how voice recognition and response work. Now, for the introduction of this, these are some of the things that we are required to know. We believe that we are able to acquire great deal of knowledge through our ears. The ear is meant for listening, and the ear is one of the organs that we are able to acquire a great deal of knowledge from. So, because of that, many multimedia developers take advantage of this sense by incorporating sound into their multimedia products. Just like adverts being played on a radio, by hearing by hearing the adverts, you'll be able to know what is being sold or what the advert is really about. So, of course, the ear is very important, and multimedia developers are in the known of that, and they take advantage of this to be able to incorporate sound in most of their multimedia products. Now, sound, in its sense, enhance multimedia application by supplementing presentation, images, animation, and also videos. Some time past, only those who could afford expensive sound recordings were the ones that could produce high quality digital sound. Unfortunately, in our current state today, computers are able to synthesize and also make it possible for the average person to also produce comparable sound and also music. So we sometimes would have an individual just being at home with certain software being able to produce some lovely sounds, to produce their own music and all of that. Now, sound in itself is a technology which is used in the form of analog form. Excuse me. Sound is a technology used in the analog form, and because it is in the analog form, we need to find a way to digitize it in a way that will be understood by the computer. So when we digitize the analog form of sound, we call it an audio. So a sound, in actual fact, is also a waveform. So it is produced when wave of various variety of pressure travels through a medium, and the propagation of sound usually happens in the air. So it is inherently an analogous phenomenon where the changes in air pressure can also vary continuously over a range of values. So in actual fact, sound, to be able to appreciate sound like how I'm speaking right now, by default, the sound is being traveled or is being propagated through the air, and it comes in the form of an analog. So as I said, the moment we digitize this form of analog sound, we call it an audio. Now, let's talk about multimedia system sound. So all computers are equipped with basic sounds such as beeps, dings, random startup sounds. But unfortunately, in order to be able to hear more sophisticated sounds like music and also speeches, one would need to have a sound card and either a speaker or a headphone. So you can have a laptop if you don't have a device to be able to um, hear the sound that comes out of these devices. It will be very difficult to know. So these sounds like the beep, the dings, and the random sounds that are being made on computers or that come out of computer, um, you will need to have a sound card to be able to hear what is going on. So in actual fact, sound comes out in an analog form, needs to go through certain process to be understood by the computer, and this is where the digitization comes in. And the moment the sound has been digitized and is understood by the computer, the same sound, for us to be able to hear the sound that is being produced, would have to be converted again back to analog signal for us to hear. So if you are not aware, all the Mac PCs and also laptops that we have, they all come with already existing sound card. So if you have a laptop or a computer that is unable to play sound, then there is a likelihood that your PC does not have a sound card, or the PC or the Mac or laptop does not have the drivers that will run the sound card, which is the hardware. In your introduction to computing, you were told that um, computer is made up of software and hardware. So the hardware is able to work. It's just not functional until there is a software that runs on the hardware. So in the same way, if a PC has a sound card and does not have a software to run that sound, it becomes it becomes difficult for the PC to produce a sound that it tries to play. Now, to see if a sound card is installed on a PC, there are certain steps that you can go through to be able to do that. Usually, when you check under Device Manager, you'll be able to see the sound card available in there and see if those appropriate software have been installed to run the hardware sound card that is installed on the PC. And again, to test the sound and volume on the computer, you can go to settings control panel and try to play some of the inbuilt sounds that comes with the PC or the MacBook. Or if you have any audio file that is on the computer, you can play it to see if sound would really come out of the PC. Now, let's talk about digital audio. So that is about multimedia sound systems. Now, let's talk about digital audio. Now, as if you recall, I spoke about this earlier. So the sound which is recorded on an audio tape through a microphone or from other sources is in a form which is analog. By analog, we normally term it as a continuous form. So have it in mind that anytime you record a sound or there is a sound which is on an audio tape, which is being recorded through the microphone from the source. That sound is in an analog form. So the analog form must be converted to a digital form for it to be able to be stored on the PC. So this process is called digitizing. So the method used for digitizing sound is called sampling. So sampling, in actual fact, is the process or the method that goes through by converting analog form sound to a digitized form sound that is understood by the computer. So a digital audio represents a sound stored in thousands of number of samples. So as I said, the method used for digitizing sound is termed as sampling. So in an exam or a quiz, if a question is asked as what is sampling, we should know that it is a method and a process that is used to convert an analog form audio to a digital form audio. So that is sampling. So usually the quality of the digital recording most of the time depends on how often the sampling are taken. So if the digital data represents the loudness at discrete slice of time, it is not the device dependent anyway. And sometimes some of this a sound of the same which is recorded or played at the same time might vary. And there are ways of converting these digital data, which is sound in the computer, to an analog for us to be able to understand. We'll go through those ones. But as we move on, still on the digital audio, let's talk about how, the preparation that we go through to be able to digitize an audio file. So from here, you can see, so to be able to prepare digital audio files, these are some of the things that you have to go through. And most times, you should be able to go through certain steps, these steps, to be able to prepare an audio file. So the first one is to be able to balance the need by way of balancing the need for the sound quality against the available RAM and the hard disk source. So usually if to get a very good audio file, if you want the best of quality, then it means you will be able to you will be using the RAM, more RAM, to come out with the best of qualities when we are preparing your audio file. So if you use less RAM in the preparation of the audio file, then it means the quality of the sound, will reduce. So setting appropriate recording levels to get a high quality and also clean recording. And again, to digitize the analog material recording into computer readable digital media, the sampling rate determines the frequency at which samples will be drawn for the recording. Now, you should bear in mind that the number of times the analog signal is sampled during each of these periods and transformed into a digital information is called the sampling rate. So in this case, you can see we have an analog sound which is converted to a digital sound. And we are saying that the number of times that the analog sound is sampled during each period. So there is a period here, meaning period has got to do with time, rate, and transform into a digital information is called a sampling rate. So a sampling rate are calculated in hertz. So it's a frequency. They are calculated in hertz. So the symbol is Hz, or sometimes it's also calculated in kilohertz. So the most common sampling rate that is being used by multimedia applications is the 44.1 kilohertz, 22.05 hertz, and also 11.025 kilohertz. You should also have this in mind that sampling at a higher rate more accurately captures the higher frequency content of the sound. So because of that, the higher sampling rates means higher quality of sound. So when you have a sound of very good quality, then you know that it has gone through a higher sampling rate. That is by saying there has been a number of times that the analog sound was sampled during a specific period of time to be converted to a digital information. Um, you should also be mindful that conversion from a higher sampling rate to a lower sample rate is also possible. So if you have a very high quality sound and you want to reduce it a little to a low quality sound, it's also very possible. Um, you can, if necessary, downgrade the quality of the sound to something that is still usable, but the quality goes down. If you're not aware of this, you should be mindful that audio resolution determines the accuracy with which a sound can be digitized. Now, still on sound bit depth, have this in mind. So you can see from here that this is the original wavelength. I said sound is more of a wavelength. This is the original wavelength, and this is a sampling frequency. And this is a sampled data. So from the wavelength, that is the data that is being sampled, as you can see in here. And once we've been able to sample the data, we will be able to reconstruct the waveform, which is over here, the waveform. So by reconstructing it, this is how it will look like, which is quite similar to what we see in here. Now, sampling rates and sound bit depth are the audio equivalents of resolution and color depth of a graphic sound, a graphic image. So in graphic or pictures, or just like our screen, or even in some movies or picture qualities, we talk about the resolution of the picture or the resolution of the graphic. And that has got to do with pictures and also graphics. Now, when in sound, when we talk of sampling rates and sampling bit depth, that is equivalent to saying resolution in graphics or pictures. So the higher the resolution, the better the picture or the graphic. So in the same vein, we can also say the higher the sampling rate and the sound bit depth, the better the quality of the sound that is being produced. So bit depth depends on the amount of space in bytes, which is used for storing a given piece of audio information. So the higher the number of bytes, the higher the quality of the sound. So just like how I explained, multimedia sounds usually comes in the form of 8 bits, 16 bits, 32 bits, and 64 bits formats. So an 8 bit has 28 or 256 portable values. So if you have an 8 bit um, multimedia sound, it could be in the form of 28 or 256 possible values. So um, so that is how the multimedia sound looks like. So for instance, if you have about um, 4 of the 8 bits, you have 8 bits make a more or less like a character. So if you have 4 of 8 bits, and so 1111118, 4 of that, so 11118, so making 32. If you convert, 8 bits itself, 1111, 8 bits is just like saying maybe 1111 as in on. So 11118 of them. If you convert one which is up to 8 in base 8, let me see if I can write it in here so you understand. So for instance, we have 1 1 1 1 1 3 5 6 7 8. So this is 8 bits. So taking a scenario where all these bits are on. That is why we have 111. And this is, computer understands zeros and ones, zeros and ones. So meaning it is in base 2. So 8 of these ones is in base 2. If you should convert it to base 10, if you should convert the whole of this base 2 to base 10, you will be getting 256. So that is what is being said over here. So 256, that is where the conversion comes in. So if you have 8 bits, which is on, converting it from base 2 to base base 10 will give you 256. So a single bit rate and a single sampling rate are recommended throughout the work, and usually an audio file size can be calculated with a simple formula. This formula is very key, and I would advise students take note of that. So to be able to know the file size on the disc or the file size of the audio, the formula is the length in seconds times the sample rate times the bit depth over 8 bits per byte. So let's take an example, as you can see here. Let's take an example, as you can see in here. Just a minute. Okay, let's talk about the example that we have in here. But before that, be mindful that bit rate refers to the amount of data, specifically in bits, which is transmitted or received per second. So it is comparable to the sample rate that refers to the digital encoding of the sound. You should also be mindful that it refers specifically to how many digits, once as in how many digital per, for instance, 1 second or zeros, how many ones or zeros are used each second to represent the sound signal itself. So this means that the higher the bit rate, the higher the quality of the size of the recording. So for instance, if we have an MP3 file, which has a bit rate of 320 kilobits per second, or which is sometimes referred to as kilo is in thousand, so 320,000 bits per second. This is an indication that the amount of compressed data needed to store 1 second of music is 320,000 within a second. I don't know if I'm making sense here. So have it in mind that bit rate is the same as, in mathematical sense, bit rate is equal to the sample rate times the bit depth times the number of channels that it falls within. So taking this example for a good illustration, let's consider this. We have a standard audio CD, which is said to have a data rate of 44.1 kilohertz per 16. That is per 16. So implying that the audio data was sampled 44,100 times per second with a bit depth of 16. So the CD tracks are usually in stereo. So as we already know, we have mono and stereo. The sound quality of mono is not realistic, but when we have a stereo sound, it is more realistic. You're able to hear the left and right. Mono is more of one-sided sound. So with a stereo, you're able to hear the actual quality of this. So in this case, most of the CD tracks that we produce usually comes in the form of a stereo. So using by stereo, It means we are able to use the left and the right tracks. So the amount of audio data per second is doubled that of the mono, where only one signal track is used. So as I said, mono uses just one path, but with the stereo, we have both sides given. So with the formula of bit rate given as the sample rate times the bit depth times the number of channels, we can say the bit rate is then 44,000 samples per second times, that is the sample rate. The sample rate is 44,000 samples per second times 16 bits per sample, that is the bit depth, times the number of channels. And in this case, the number of channels is 2 because it's stereo. If it is mono, then the number of channels is 1. I'm going to give you the PowerPoint slides together with the handouts, so you would be able to do some of these calculations in there. So in that case, we have 16 of the bit depth, 16 bits per sample, times 2, which is a 2-channel. So in the calculations, when we do the multiplication, we'll be getting 1,411,200 bits per second, which is equivalent to saying 1.4 mega. Mega is million megabits per second. So in actual fact, this particular standard audio, which is going to be burned onto the CD, will occupy a space of 1.4 megabits per second. So that is a standard CD, which will be used to have the data rate which has been given. So that is a calculation for the bit rate. Now on the next slide, I'm going to give you 2 more other scenarios. So for instance, let's take this one. Let's go to the next slide. Yeah, so the, still on sound bit depth. So you have two more questions in here, which I would want you to solve. And I'm going to go through it with you. I'll go through one with you. Then you try to solve these ones as a leisure. Anybody who is able to solve it can put the question in the forum and tag the solution in the forum. And our advice students can also go there and check it out. In the exams and quizzes, these are some of the questions that I'll bring. So please try and get these formulas right. Now, the question is, what is the bit rate for a DVD that has a sample rate of 48 kilohertz, a bit depth of 24 bits, and a 5.1 channel of audio? So in this case, you are told to calculate the bit rate. In this case, you are told to calculate the bit rate of just a minute. In this case, you are told to calculate the bit rate of for a DVD. So the first thing you have to have in mind is the formula that has been given. The formula says the bit rate is equal to the sample rate times the bit depth times the number of channels. So with the question given, what is the bit rate for a DVD that has a sample rate of 48 kilohertz? So the sample rate has been given to be 48. The bit depth has been given to be 24. And the channel has also been given to be 5.1. So to calculate the bit rate, it will be per the formula, we would have 48 times 24 times 5.1, which will give us 5,908.8 kilobits per second. So that is going to be the bit rate for the DVD, for this particular DVD. So this is also the next question that has been given. Please try and solve this particular question. And those of you, and this question is also one of the questions I would want you to solve. With this, you were not given you have been given the bit rate itself, but you were told to calculate the number of channels for a WAV file that has a bit rate of this and a sample rate of that. And the bit rate is 16 bits. So of course, we'll make the number of channels the subjects and you do the calculations for the bit rate, for the number of channels. Because the values for each of the other parameters have been given. The bit rates, the sample rates, the depth rates, the bits depth have all been given. So you should be able to do the computation to come out with the calculation for the channel. Now moving on. Now let me explain what the mono and the stereo is. I've already talked about it, but let me just reiterate on that. So you should have it in mind that mono sounds are flat and unrealistic, which is whenever we compare it with the stereo sound. So which is more dynamic and also lifelike. By lifelike, we mean to say that the sound that we hear from a stereo, is more realistic, because it's able to go through two channels. But with the mono, the sound is more of one-sided, so the quality is not so good. So for instance, if you have a headset on and you play a sound which is mono, which is a mono sound, you might be able to only hear one of the earpiece, one of the headsets, producing the sound. The other will not produce the sound. So that is how the mono really works like. For the stereo, the sound is being played correctly in both ears through the headset. So with this in mind, you should also know that the stereo sound files requires twice the storage capacity of mono sound files. So with that in mind, that should tell you that the size of the mono sound files is quite smaller compared to that of the stereo sounds, mainly because they have double channels. So of course they will have extra size to be able to come out with better quality. So stereo files are quite heavier than the mono sounds. So in that case, if storage and transfer is of concern to you, then it means if you really want sound to be produced, but you don't really care about the quality, then you can go for mono. And again, if the size of space that the sound is going to occupy is of concern to you, then it means it is not necessary for you to go for stereo, because stereo is going to give you extra file size, but mono is going to give you just a small sound file size. Now, the formula for determining the size of a digital audio is also given, as you can see in here. We have, in fact, there are two. We have the monophonic. That is a way to be able to determine the size of a digital audio. For the monophonic, the formula is monophonic is equals to the sampling rate times the duration of the recording in seconds times the bit resolution over 8 in terms of bits times 1. 1 because it is mono. The channel is 1, which is mono. But for stereo, the channel will be 2. This channel will be 2. That is going to be meant for stereo. But for monophonic, this channel is going to be 1. So keep the following things in mind. That the sample size is the amount of information stored in, and it's called bit resolution. That is the one thing that you should keep in mind. The second thing is the time span of a recording is measured always in seconds. The last one is the number of channels is 2 for stereo, 1 for monophonic sounds. So still on monophonic sounds, these are two questions that I believe you should be able to solve based on the formula that have been given in here from the previous slide, this formula. Now, the first question which we're going to discuss is you are told to calculate the size of a monophonic digital audio file that is 5 minutes long with a sampling rate of 44.1 kilohertz and a bit resolution of 16 bits. So from the definition and the calculation given, we can say that the monophonic digital audio file is equal to the sampling rate times the duration of recording, which is what has been specified here, the sampling rate times the duration of the recording in seconds, times the bit resolution per over 8 times 1. So 1 mainly because it is monophonic. So from this question, we can see that we have the sampling rate to be 44.1 kilohertz. We've been given the time to be 5 minutes. And I told you from the beginning that, all the time is, the time computations should always be converted to seconds. So it means 5 minutes converted to seconds is going to be 300 seconds because 60 seconds is equal to 1 minute. So 5 minutes is going to be 5 times 60. It is going to be 300 seconds. So we have a sampling rate of 44.1 kilohertz times 300 seconds times 16. We've been given 16 bits. So that is a bit resolution. And that's 16 bits over 8. 8 over 8, which is the 8 we have here. So the bit resolution is 16. So over 8 times 1. So the final answer will be 26.4 megabytes. So that is going to be the monophonic digital audio file size that we would have. So therefore, the size of a monophonic digital audio file will be approximately 26.4 megabits. Let me see if I can quickly put up this solution for you to see in a text file so that you can appreciate it. Just a minute. Let me pause it and check this. Okay, I'm back. All right, I'm back with the recording. So this is the solution for this particular question. So as I said, these you have to go through it. This is the formula given. So in a case where we've been told a stereo digital audio, it means this would have to be 2 and not 1 because the channel for stereo is 2. All right, so I expect students to be able to solve this particular question. Yes, so please make sure you're able to solve this question. Those that would want to put it on the forum, you can put the question there and you can solve the question in there for your other colleagues to also see. All right. All right, so now let's talk about analog and digital signals. We are still dealing with sound, so let's talk about analog and digital versus digital. So generally, there are two types of sound. So anytime you hear of sounds, there are two types of sound. We have the analog sound and also the digital. So the analog sound is a continuous stream of wave sound. And also, to be able to understand, um, for the computer to be able to understand this particular sound, these sound wave must be converted to numbers. So as I told you, the computer doesn't really understand anything but zeros and ones. So in this case, the conversion into numbers is what I'm talking about as zeros and ones. So to be understood by the computer, which is the analog sound, which is a continuous stream of sound waves, these sound waves might be converted to numbers, which is the zeros and ones, which is the only way a computer understands. And that process of converting from analog sound into um, numbers is what you term as digitizing or sound sampling. So the process of converting from analog sound to numbers that is understood by a computer is termed as digitizing or sampling size. Now, analog sound that have been converted to numbers are digital sounds. So you should have in mind the moment we convert that analog sound into numbers, which is stored in the computer, we call it a digital sound. So when we are working with digital sound, we call it audio. So you should be mindful of some of these things. The moment the conversion is done, we call it digital sound. The moment we start working on the digital sound, we call it audio. So therefore, sounds that can be converted from analog to digital is often called digital audio. Should be mindful of that. Now, non-constructive sound processing method maintains the original file. So a copy of the original file can be manipulated by playing it louder or softer, combining it with other sound on other tracks, or modifying it in other ways. So the sound that we have, we can do put up certain processes to do other things. We can make the sound louder, we can make it softer, we can incorporate other kinds of sound tracks to the sound and modify it in so many ways. But there is a catch here. So anytime you are using non-constructive processing, the original file should remain untouched. In this case, it is needed at a later time. So using a non-constructive processing, the original file should remain untouched. We don't have to touch the original file. And the reason is for later use, we might want to come back to the original file that we've been working with. So the moment the sound has been recorded, digitized, processed, and incorporated in a multimedia application, then we can say this particular sound is ready to be delivered to maybe the general populace. So by delivering it to the general populace, then we can say you and I can hear it through our speaker. Digital sound is sent through the DAC, which we term as a digital to audio converter. All right. So the delivery system, and that is how, as I talked about, we can deliver it to general public for people to appreciate it. So with the delivery system will vary as the intended audience of the multimedia application changes. So when considering the delivery of the sound, one should be able to consider the number of different sounds that will be delivered, how they will be delivered, and where they will be delivered, and to whom they will be delivered to. So in this case, we mean to say that the application may include one voice and some background music designs for one user in front of a desktop computer. Or it may also be a presentation with various different types of music, narration, and also special effects design for a larger audience to be presented in an auditorium. So it depends on where we're going to deliver the sound. Certain things need to be done to the sound to make it appropriate for such, um, set devices that are going to, do the playing of the sound and at what location is going to be played. So as you can see here, so whenever you're considering the delivery of the sound, you should consider the number of different sounds that will be delivered, how they will be delivered, where they will be delivered, if it's an auditorium, and to whom they will be delivered. So regardless of all these, a high quality delivery system will help ensure that most of these sounds we have worked hard to create make the right impression to the audience. So we just don't want to do anything, but we want to be able to produce sounds that possibly might be able to, work on all platforms. So the types of sounds of digital audio files, these are some of them. So there are many different types of digital audio file formats that have resulted from working with different computer platforms and also software. Some of the better known formats include, that is what we're going to talk about. So virtually, just like how some players are unable to play certain files, which are audio, in the same way, certain software or operating system also have their specialized audio file formats that they require to be able to play some of these audio files. The first one we're going to talk about is the WAV file. So that is a type of digital audio file. And the WAV file, these are some of the things that you should know about the WAV file. It's a waveform format, and is the most commonly used and supported format on the Windows platform. If you're talking about Windows platform, and it means this format comes with your Windows operating system. The Windows operating system was developed by the Microsoft system. So that should tell you that the WAV file was developed by Microsoft. So the WAV file format is a subset of these, the RIF and the RIV, which is capable of sampling rates of 8 and 16 bits. So that is about the WAV file. We also have the AU, which is sound audio format. And this was developed by the Sun Microsystem, which was to be used on Unix and Sun CPAC workstations. So that is also an audio file that was developed by these companies. And this company is a Sun Microsoft system, Sun Microsystems. So in an exam or in a quiz, if we talk about some of these file formats, we expect you to know which organization produced them or which organization, came out with these file formats. So please have this in mind. So it's also a 16-bit compressed audio file format, which is fairly prevalent on the web. So you will see on the websites, audio files that are of the format AU. All right, so now let's talk about the next one, which is RA. So RA is a progressive network real audio format. It is one of the very popular formats for streaming audio on the internet. And the reason is because it offers good compression up to a factor which is quite better or good. Compression up to a factor of 18. I'm sorry about the omission. So, in fact, we say it's very popular mainly because, again, it offers good compression up to this factor of 18. Because of that, the streaming technology is able to, streaming technology behind RA enables a sound to begin playing way before the entire file has been downloaded. And so, because of that, most people will also produce files, audio files for their websites using this particular format. Now let's talk about the other one, AIFF or AFF. It's also an Apple Audio Interchange File Format. Apple Audio Interchange File Format. And this is supported by IBM compatibles and Silicon graphic machine. The good thing is AIFF formats support a large number of sampling rates, up to 32 bits. Some of the previous ones were 16 and also 8. But this one has a higher sampling rate. We spoke about sampling, what it is. MPEG or MPEG-2 are motion picture expert group in a format. So please, when we talk of MPEG, so MPEG, these are all acronyms. You should be able to know what it stands for. Motion Picture Expert Group, just like when we start talking about graphics. JPEG, that is Joint Photographic Expert Group. You should be able to know some of these acronyms. So some of the websites use these formats for their audio because their compression capability offer up to a factor of at least 14:1. These formats are will probably become quite widespread, mainly because as the price of hardware-based MPEG decoder continues to go down, and as software decoders and faster processors become more mainstream, we will be seeing more of the MPEGs, mainly because of that. MIDI, um, which represents, which is an acronym for musical instrument digital interface. So it's an internationally accepted file format used to store musical instrument digital information data. And it is a format which is used to represent electronic music produced by MIDI devices. In fact, most of the format that is stored in MIDI is quite small. When you store your audio in MIDI, it doesn't really consume much of space. The format provides instructions on how to replay music, but it does not actually record the waveform. The next one is SND, which is sound file format, which was developed by Apple again. It is mainly used within the operating system and has a limited sample rate of 8 bits. So for multimedia applications to work on both PCs and also Mac, save it using either the musical instrument digital interface, which is the MIDI, or the audio interchange file format, that is the AIFF file format. So digital recordings. So generally, in digital recordings, the digital sound can be recorded through microphone, keyboard, or DAT, which is the digital audio tape. Now, to record with the help of microphone connected to the sound card, is avoided. The recording that goes through microphone, which is connected to the sound card, is not really the best, mainly because some of the sound amplification and all recording and recording consistency are issues. So recording on a tape recorder after making all the changes and then through the sound card is most of the time the recommended approach to, to put up recorded sound onto PCs. While this statement is suggesting that the recording directly into a sound card using a microphone is not recommended due to the potential issues with sound amplification and recording consistency. Also, because of that, it is most of the time recommended to first record on a tape recorder and then transfer that recording onto a computer through a sound card? Well, generally, there are a few reasons why this may be the case. And the one reason is that some of the sound card may not have the high quality preamplifiers for the microphone input itself. And because of that, this can lead to noise and distortion in the recording that we'll be producing. So by recording onto a tape recorder first, you will be able to use a high quality preamplifier and also avoid some of the issues of recording consistency and also sound amplification. There is also another reason why it is best to record onto a tape recorder, and this is mainly because this would help in the provision of a consistent and also reliable recording level. And by having a consistent and reliable recording level, it will become very difficult to achieve when recording directly onto a sound card. That is very difficult. And due to this, the sound level can vary depending on the distance and the position of the microphone, as well as the acoustics of the recording environment. So if there are sounds around, the further you are away from the microphone, it means you might lose some of the originality of the sound that is actually coming. But however, if you go this tangent by recording on a tape recorder first, you can be able to, or you would be able to adjust the recording level as needed and then transfer the recording onto the computer with a consistent level. So generally, the statement that has been put across up there will mean that recording can be done in two approaches. The first is to record, either record through the microphone, which is connected to the sound card, which is not the best. Rather, the second is also to record on a tape recorder after making all the changes and put on the sound card. This is the best of options, mainly because you're going to get very high quality of sound. All right, so I'm going to end here and continue lecture unit 3 again, the second part of unit 3 later. Thank you very much.